Yeah, you see sharps. That's one of the cool things about a translation operator before a what is it, harmonic oscillation operator or harmonics operator. Well, I don't need it to harmonically go over on pi waves, but it will because that's the translation about what we're doing.
Ever wonder how complex exponentials make quantum mechanics
Space
tick?
U.
Welcome back,
It's gonna be
everyone.
SO2
Today,
or
we'll revisit
SO1,
our
which
old
is
friend
a
Hermitian in the
second
new
order
light of
operation
unitary
numbers. Board
operators.
cut first day,
You know,
board
the
cut
things that you
second
see
day, board
all
cut
over
first week
particle
of the
physics in
first
the
day,
standard model.
board cut
Yeah, the
first
things we talked a
second
lot
week of
about
the
in the last
so on and so
big
forth.
video with the standard model
Well, the
Lagrangian.
periods.
Yeah.
Because it's going this way. Well, how does something go back in time? How does something negative 1 off of what 0 to infinity is 0 to infinity, 0 to infinity, and on XYZ plot? Well, that's because it's not. Essentially, there's a Penzrow diagram for it, which is saying that there's a 45-45 in each of these departments, and if you're going into the first order, then this is high, marginally prepared beyond that, which is not quite. There's a quintessence or a factorial between these distances being even between those periods, and let's say I was running a double operator. Well, from a negative standard, I would have to understand that. I would have to have some second order operation or that second week or second month or second year to correlate that wave data, right? Like, so a harmonics oscillator is going to come up on pi waves. This is coming up on sine waves or SU waves, which a sine wave is essentially as a high cycle, one pang, from 0 to 1. Between X and Y on a 0 to infinity timeline, nothing. It all goes down. But what is kind of pops up or it holds there, now that becomes 1. So inside of there, that's an increment of measurements that is a translation. It's ontology for numbers in that form. Not all numbers are going to be the same, and as you're reading some pressure gauge screen or the Weeble stock, there's multiple different organizations or entropies to that all serve some SO or SU order, right? Because it all can be XL'd. That's generally your SO order. They're not automated, they're not animated, and so they can't really specify what's in here. But with that automation, animated anything or just this 0 or 1 increments is not necessarily what's correct either. It's when you're positioned relatively, they're both A, but one would be in relation, not just relation, but in orientation, left, right, up, down, a negative to that situation here on the timeline as well, that you would have to specify all this is going to happen after some timeline because that's first and second order operations. Right, and it doesn't matter how you get up and going down about that. It's in here on that figure 4 before we get into spin, SU2, and at times SU2, which is to say that standard was here's this original framework, here's this original framework moving, right, and that's going to determine its probability under its own head for the XL on your budget. But budget is again a loose term, right? It's a bit of an acronym or a homonym to the issue. Let me keep going.
Yeah, all of them coming together. Even some of these nice, what we see with these diagrams. Yeah, they all.
Well, again, being that this is Bohr model, this is first order. It's a squared circle problem. We have an arc sine, right? We have a sine and a cosine. That if this is its sine, or its number as an operator, depending on which we believe is the first order, right? Then you would say that is how did I want to word that? In the Bohr model, in emission or absorption. So as you turn this thing like Gaussian, you orientate it to an axis. It would be an axis of some kind of 1, 2, 3, M1, M2, Mn. But that's inside. Yeah, it gets a little trippy. I need a lot of this other stuff.
They all come together.
And again, we're just using a 0 environment here. This is just 0. This point here could be anything. We don't know what that is or how to quantify something to that point invertly.
Here. So
Bar.
we'll
In,
explore
in
why
a
the
bar
exponentials
review.
of Hermitian operators is always unitary with a simple sketch proof. Let's dive in. Alright, so in this question, We are tasked with showing that for a Hermitian operator Q, the operator U, which is an exponential with IQ, is unitary. Okay? And then he gives us this idea
Numbers. I do things in a time frequency numerological NP domain.
of, with a hint, that first you need to prove that the adjoint is given by same
No,
operator
this
with
is
the dagger,
salty.
again, conjugate transpose, is equal to the negative in the exponential. Then all we have to do is prove what U dagger U is, and hopefully that should come out to 1.
3 point, problem 3.4 may help. I don't know what that is. But let's go back. Let's break this down in terms of quantum mechanics. And again, this is a Hermitator operator. All right, whatever. Hermetic operator, sure. You are the Q hat. What does that mean? All questions are usually answered by you. You are the capital form of Q. Q's are questions. People ask you questions. You're the one that wears the hats that answers that question, right? Well, it makes sense here. Why would it make sense here against the right-hand rule of a school? Is relative. We would have to build that in a numerological unitary model. But let's get back to this. The operator is you. So again, he's the questions. I can do this, but right now, and this is not done, he's going to form this statement that is posed as a question that will break down into an IQ black body. Now, what does that mean? That means that I understand this so that I am a Q hat as well. I'm maybe not Beat Picard or Q on the Starship Enterprise, but for most enterprises I do, it's easy enough to recognize what that is. And then there's a capital form of U. There's kids, or uniform I hat, to J hat, this distance and this distance, numerologically, regardless of what that is 1. That we understand that there's a difference between, this case, Milgram's the teacher, and in this case, the student, if only based in orientation. And we can figure that out by unitary measures, by testing the hats in each regard. If you're asking questions, then you are this U hat, and you're an adult range of it. Should seem like some more advanced questions than Goo Goo Gaga and How to Say Daddy, right? The letter A we'll get back into in a minute. This is an IQ. We don't have this done yet, so we're going to assume that the Q hat forms the questions in terms of their units. It does not need to be ASVAB. It can be any numerological set that you do. If the IQ test gave you ranges of minutes, math problems, minutes, and reading comprehension questions, or overall, or independently, any one of those sectors, or overall, all of those, they still have a quintessence to the exact spot that you're in. The initiative bar, back to this is a bar. We're just looking at it like it's coming at us, and I don't have the Gaussian in terms of how long it is, because as you're looking down the shotgun, it's just a barrel. If you didn't know things about the shotgun, well, then that would change how the physics is perceived. Not necessarily, matter manipulation here, but it brings into, well, what questions would you act differently in terms of their unitary measures? First, you need to prove that the adjoint Q, or this J, to the distance is I hat to J hat, that these are uniform temperatures. This is a length between X and X1, or X and Y, depending on where that orientation is on that operator. First, you need to prove that that is salty dog, that this is the adjective or the conjunction. The conjunctive, the conductor in that way is a good way to do it, but I like it to say that there's a spear right there. That's the guy that's some Marine that's wearing this hat that asked the question to upper command, because not that they couldn't figure things out, but if there was a way to geodesics on that timeline, that's the one you have to know by a unitary measured in the box by what would invert that person's IQ. If I asked them questions, I would get 80% of that test right, that they knew the answer, not necessarily a truth or false or random, I can't think, there you go, TV. And we're explaining that by saying without them there, that they were providing this question to go into there. So if we remove that, let's say a little delta, or this understanding of I hat and J hat and Q, yeah, you gotta uncipher this ontology, because A is Alice and Bob, remember, and they're going different directions in a plane and a car about what time dilation is in protracted warfare. Okay, so that's what I've subtracted. The square root of -1 is I, right? Well, that means that the square root, or the fractal, the divisible, the multiple of -I is going to be 1 or 0. It can only be those two things realistically, and that means it's high and low in terms of a numerological time frequency domain. And that's whatever you look at, because again, you're only going to get 2 or 3 parts. When you do measure theory, there is 1 inch. There is 1 inch. It is all the way. We divided that in half, and that gives me a signal, let's say the lifespan of a human. What do we know about those things if they were unitary? Right? There's all kinds of different ones. They have different ranges to get there, but they still define the overall particle slit experiment of this Gaussian, right? Because from here to here, we don't need another diagram that says what that spot is unless we're utilizing that as a position. It could be anywhere in here, but because of that, it can only be -1, or it can be 1. It can be 1, or it can be -1. And in that way, it'll always skip into there and always start back to this origin source, like this loop or geodesics in a manifolding system. That's your stone mason's cut, because again, as for the operator here, Q, this ground guy manager that has to ask the company what the question is here, again, the Q for the U on an IQ. By asking certain positions, not random, how much carbon dioxide's in the air at any given time is the wrong type of bracketed question to get to the proper unitary measure, or the muon that I need in that aspect that is not the electron, and more abundant than, or at least more massive at the level of translation operators. That seems to be where they are lining up on the pi waves Fourier. And so yeah, that's going to give you a lot of this, and why you can do this. That's where you put the sword in the ground to make a force. There is a question and a difference about what that is, equally like the example in breaking this down into one real stone mill, or the trapping of that rabbit in an event of a farm and its workers, its bosses, its kid, its employees. Whichever way you can do that, they all base into these, what are I hat, X to Y, I hat to J hat, uniform temperatures that all have that, no matter what the difference is inside of there to that measure. And anyway, there you go.